Hey, you want to upgrade your charging system on just about anything? Check this out. Hey, I'm Evan, Head of Engineering for RMSTATOR. Today we've got an interesting video for you that it's not one of our typical installation videos. Today we wanted to show you our universal voltage regulators and show you how you can use them on lots of different things out there. These can be used on just about any fitment for motorcycles and ATVs, UTVs, even some watercraft, snowmobiles. So I wanted to show you how our universal voltage regulators can apply to all sorts of stuff. We thought we'd show you on this Harley here. This is my old Dyna. It's a 1998 Harley that has had a stator conversion to a 3-wire stator. So we'll talk about that in a minute. But I thought it was a good example to show you how to use these universal regulators on, because this is not a bike that you would ever normally see one on, but you totally can, and it's a nice upgrade. So we'll talk about that in a minute. First, I want to show you what type of stator and flywheel charging system that these can be used with, and then I'll show you some of the options. So we're going to bring the camera in and show you some of these parts. So the first thing I want to talk about is what type of charging systems that these can be used on. All these regulators are a 3-phase type, or a 3-wire input from your stator, and they're for permanent magnet charging systems. So what that means is you have to have a charging stator in your motor that has 3 wires coming out of the stator and going into the regulator. So this is not a stator for this Harley. I'm not even sure what it's for, but it's just a good example of a typical stator with 3 yellow wires. Usually the charging wires coming off of the stator are yellow or white, but they can be other colors depending on application. The other thing is it has to be a permanent magnet charging system, which means it has a flywheel like this that has magnets embedded in it. And don't worry too much about this. Most modern motorcycles and ATVs use this type of system. Your stator might have some other wires coming out of it for a pickup coil for timing purposes. Some have a neutral switch or other things run through them. But you can always trace your stator wires up to the voltage regulator and see. If you have 3 wires from the stator going into the regulator, that's the type of system we're looking for. Otherwise, if you're not sure, an internet search usually makes it pretty quick to find pictures of your stator or people discussing the system for your vehicle, and you can find out for sure. You can always contact RMSTATOR as well, and we'll be happy to help you. Okay, I'm gonna get these out of the way. Okay, so I wanted to show you on this Harley because this is not a typical application for this. Most of these Harleys of this era used a single-phase stator, which would be a 2-wire stator, just had 1 coil wrapped on the stator. The systems we're talking about that our regulators work with are 3-phase or 3-wire, which means they actually have 3 coils that are tied together on the stator. And you can see, like, here is the original regulator for this bike. Has a pretty unique connector that was common just to Harleys. It only had 1 wire running out to the battery. It grounded itself through the frame, through the mounting bolts. So it's pretty unique setup, common to Harleys, but like really only for Harleys. This wasn't used very much on other applications. However, this particular Harley, I use this bike as a test bed for a lot of our parts, so I converted it a while ago to a 3-phase stator. So it does have a 3-wire stator in it now. Not super, super common, but it makes this a good application for a lot of our universal regulators, because now it'll function with them. So, you know, I want to show you guys that, like, if you're building a custom bike or something, you can totally use one of these regulators, or you can upgrade a stock regulator to one of these. And I'll go over the different types and show you why they're better options. First off, you can see, looking at some of our universal regulator options, all the housings are pretty similar. I mean, they're different, slightly different shape and size and different mounting hole spacing and all that, but they're generally pretty similar, right? Well, we designed most of these after the case size and case design used by Shindingen. They made a regulator type called the FH020, I believe, that became very common and popular and is used by Yamaha and Honda and a lot of other OEM manufacturers. And it's a good case design, it's a good size, the mounting hole spacing is pretty common, so it makes it a very good option for a universal case because it makes it easy to fit and replace on lots of other fitments. And most of these, not all, but most of these have slotted or very wide mounting holes, which make it apply and fit on lots of models because you don't have to have exact mounting hole spacing. You can just get it within the slotted area. The other benefit is that they use this connector type, which I don't want to say is like a fixed standard, but like it's kind of getting there. It's very common. These are sealed waterproof connectors, so they're really excellent. The connector that plugs in over them has a rubber seal on it and a boot on the back of the wire, so it keeps water and moisture out of the plug. And this has kind of become standardized. The gray connector here is usually the stator input connector, and you'll have 3 terminals on it. Your stator wires come in here and they can go in any order. There's no polarity to them. It also has a keyed locking tab on it, so only the right connector can be plugged into it, so you can't mix up the battery and stator side. And then usually, not always, but usually the black connector is the battery output. And on a lot of these, looks like not this particular one, but a lot of these will actually have a plus and a minus molded into the bottom of the connector here, so you know which is which. But they'll have a battery positive and a negative. Usually the positive's on the inside, negative on the outside. And again, it's a sealed connector, it's locking, and it has an opposite locking tab on it, so you can't mix the 2 of these up. So that's why we use this generic case design, and they're all very similar because it works well, it's a good heatsink design, and it's fairly common and will fit on lots of things. Okay, so let me go over some of the types. We have here our MOSFET regulator upgrade. So this is a nice option compared to a lot of stock regulators. So most regulators are a shunt type regulator, which means they regulate by shunting current from the stator away from the battery, not sending it onto the battery. That current can be consumed as heat and dissipated in the heatsink here. Most stock regulators or cheaper regulators use a switch inside to do that shunting called an SCR. We don't need to go into too much detail, but it's just an inefficient switch. It generates a lot of heat and it can't switch very fast or efficiently. This upgrade is a MOSFET type, which means we use a transistor inside to do that switching. The transistor can be controlled much more accurately and it generates a lot less heat in use. So it makes it a really nice upgrade over a typical or cheaper standard style regulator. We also make, let me show you this one. Here's another one that is a MOSFET type as well, but this is specifically for lithium batteries. So we make this with a different voltage regulation point and some filtering inside, so you have a really clean output and it's perfect to use with lithium batteries. And it's in a universal case design, comes with mating connectors, so you can apply this to just about any bike or vehicle that you want to use a lithium specific battery on. Okay, another type of regulator we make is our series type of regulator. So compared to the shunt type we just talked about, the series type actually regulates by having switches in line with the stator input to the regulator. So to protect the battery voltage from overcharging, those switches actually open and close inside, again using transistors, which are efficient, and prevent stator current from flowing through the regulator and out to the battery. That makes for a really efficient regulator. It lowers temperatures in the stator windings, and the internal electronics on the regulator stay cooler. So all in all, it's a really nice option and a really nice upgrade, especially on vehicles with problematic charging systems. So here's our series regulator in a small housing using our cast aluminum heatsink. And then this is really cool. We make a couple options. I don't have all of them here, but we make our MOSFET type and our series type in this CNC aluminum, billet machined aluminum housing. So same electronics, it's a really nice upgrade, and it comes in a really nice housing that's computer machine cut out of billet aluminum, and it's a great heat sink. It really pulls heat away from the electronics better. Okay, so now that I've showed you all this, I also want to mention that we include the connectors like I talked about with terminals and seals and everything you need to crimp these onto and replace your original connectors on your vehicle harness and get it ready to plug right into the new regulator. So that's all the part types. We're going to show you kind of the specific application here on the Harley to give you an idea of how you could do this on your vehicle. Here we are on the front of the Harley, and I'm going to try and show you this. Like I said, this bike has already been modified, so I don't have the connectors and everything set up like it would be from the factory. So I'm going to kind of try and explain this to you, and I'll show some different examples. So let's pretend we had a stock Harley here. I had already changed the stator over to a 3-wire stator. So we're going to ignore for the fact that I've actually already converted over to these new type of plugs I've been talking about for our universal regulators. Let's pretend it had the original Harley connector on it or something. But here I have my 3 wires for the stator coming out. We're going to set those out of the way. here we have our stock regulator, and we're not going to be using it anymore with this new system. We're going to convert over to one of our new regulators, which let me grab one to use as an example. All right, so, you know, first thing we'd start with is disconnecting and removing our original regulator from the vehicle. So, if all my stock plugs were still in the place, I would unplug my stock regulator connector from the stator, and I would unplug the battery side, which on this Harley is just one long wire for the positive. The negative grounds to the frame through the mounting bolts. And then let's undo these and remove the regulator from the vehicle. We're not going to be using this original style regulator anymore. Okay, so let me get this out of the way. And that would be the same for pretty much any application. So here's another example. This is not, I just have a totally separate regulator and stator set on this bike. But let's pretend that was the regulator that I had factory on my vehicle, and I'm going to be swapping to the new style. Well, here might be my stator connector, 3 yellow wires here, and I'd want to unplug that. We can tell by looking at it. Here's one of our universal regulators. Obviously the connector's not the same, right? So we know we're going to have to swap the vehicle wiring over to our new connector type so it plugs in. Okay, but no matter what, I'm going to want to unplug it. Here I'm going to unplug the battery side. So I would unplug that and have my stator connector, stator wiring hanging here out of the way. I would remove my original regulator. Okay, so that just shows you two different examples of, you know, different connector types or wiring. But bottom line is, to start, we have to remove the regulator, right? Because we're going to replace it with our universal type. So the next step, I'm not going to permanently mount this here, but we have to mount our new universal regulator. So, you know, we'll use this one as an example. And it just depends what you need to do on your vehicle. Like I said, these are universal, so they're not always going to perfectly line up with your mounting holes or mounting location. Sometimes they will, a lot of times they will, but sometimes you have to get creative. You might have to mount it somewhere else on the vehicle. In this case, on the Harley, you might not be able to see it from this angle, but we have a ridge here that kind of sticks out at the top of the regulator mounting plate. And because of that, the new regulator wouldn't mount flush. So, you know, this is just not how I would end up doing it, but just an example. You might have to get creative and like use longer mounting hardware and use something to make a standoff. So in this case, you know, I could do something like this and use some nuts on the mounting bolt to stand it off of the ridge a little bit so it fits. So anyways, I can't show you for every application because it's going to be different for everything, but just know when you're going into this, you know, a lot of times it will fit in the stock location. The mounting holes are slotted, they might line up, but you also might have to get creative to mount it correctly. Okay, so we'll pretend I'd mounted a regulator, my new regulator up there. Now we have the next problem, which, like I said, on this bike I've already converted over to the new style plug. But for the sake of our description here, let's pretend here was my stator wiring coming out of the stator. 3 yellow wires, and they very clearly have the wrong plug on them, right? Like this definitely won't work. Let's pretend here was my battery connector coming out of the regulator to the battery. It clearly doesn't have the right plug on it to work with our universal regulator. So our next step is going to be modifying the existing wiring. We're going to cut off the connector and we're going to crimp on our new terminals and install them into our new connector. So that way we can use the existing wiring on the vehicle and we can make it plug right into the new regulator. So I'm not going to show you that on the vehicle here. We're going to go to the workbench and I'll actually show you how to cut and crimp the terminals on and get it ready to plug in. We're over here at the workbench and we're going to show you how to add your new terminals and connectors to your wiring harness. So, you know, like I explained, you would generally want to reuse your vehicle's wiring to the regulator because if it's in good shape and all, you just have to change a plug right on the vehicle, super easy. But sometimes, like on this Harley application, I just made a whole new harness for the regulator and the stator because I'm doing something totally kind of non-standard on the Harley. So it just depends. So, you know, maybe you're building a new harness on your workbench and you're going to add your connectors and terminals this way. But, you know, just keep in mind what I'm showing you here totally applies to doing it right on the vehicle. You would just cut off the existing connector and then add your new terminals right to the end of the wiring harness. So let's start. Pretend I had already cut off, here's my 3 stator wires, 3 yellow wires. Let's pretend I had already cut off the old connector, so I'm just have bare wires here. So here's our parts. We have our connectors, we have these yellow pieces are locking, I don't know what you call them, like a locking piece that slides in the front and it prevents the terminals from backing out. We have the terminals themselves. We have rubber seals that go on the wires that seal the back here where the wires enter the connector. And then we have a rubber seal that goes inside the connector, and that's what seals it to the regulator side connector. So I'm going to show you how to do these. First thing you're going to do is take your rubber seal, slide it onto the wire, and just push it back a bit. Then you need to strip some of the insulation off of your wire so you're ready to crimp it into the new terminal. So with this size wire, these terminals are pretty large. They'll handle like a 10 gauge wire easily. So what I'll do when we're using smaller wire, this is a 14, you could probably make it work with a 16. Most stator wiring is going to be like 12 or 14 gauge or so. So what I'll do to make it fit the terminal better, I'm actually going to cut it back maybe 1/2 inch. And I like doing the wire stripping, like to take the insulation off. I like using a sharp pair of wire cutters to do it. But if you're not used to it or familiar with it, it's really easy to just cut all the way through the wire trying to do it. So you can definitely use like I don't have a set sitting here, but a set of handheld wire strippers that are pre-sized for different wire gauges. So those are safer. This is just the way I prefer to do it. Okay, so I've stripped the insulation back. I'm going to twist it up so the wire's tight together. And then I'm going to fold it over itself to double the size of the wire, because that'll make it fit into the terminal better. Okay, next thing I'm going to do is slide the rubber boot right up to the base of the insulation, so it's right against where my bare wire starts. Then, when we're going to make the crimp, it should fit into the terminal like this. These back legs should cover the front part of the rubber boot that's narrower. You'll see there it's kind of expanded out at the back and it's narrow at the front. That's to grab onto the terminal. And then the bare wire should sit right there in the front legs of the terminal. So this will be a double crimp. It's going to crimp in both locations. When you look into the die on the crimper, you'll see we have 3 different sizes for different size terminals. And you'll see each size has a wider, hopefully I can point this out well, a wider part at the back and then a narrower part at the front, or I guess depending on which way you're holding it. Basically, when you look at your terminal, you have your legs at the back that grab the rubber boot or the rubber seal, and then you have your legs in the middle that grab the wire. So when you put this in, the legs that grab the boot at the end of the terminal go at the wider part of the die. So if you look at it from this side, you can see there's actually a ridge inside here on the upper part that it's wider at the back and then it gets narrower in the front, and that's what actually locks the legs in place. So if I put the terminal in here, you can see that if I put it in place and I try and slide it forward, it'll stop because it's actually hitting the ridge inside that'll locate the terminal. So as I tension it down, just a couple clicks to hold it. So now I have it stuck in place in the crimper, and I have it sitting here at the back, and the back legs are in place. And if I go over here, see, I can move it around a little bit, but there's the front legs in place in the die as well. So if once you have it inserted, you can't pull it all the way out because it'll hit the ridge inside, but you obviously don't want to crimp it like that with these legs sticking out all the way. So the best way to do it is have your terminal sitting basically flush with the edge right there. So then I'm going to go ahead and insert the wire. I've already prepped another one here. I'm going to insert it into the terminal, push the rubber boot inside, and I'm going to push the wire through until it just sticks out there a little bit. So just like that should be good. Then I'll start locking it down and then release it. All right. So once I take the terminal out, you'll see we got a good crimp. It folded over both legs here onto the bare wire, and it folded over the back legs onto the rubber boot. So that'll end up with a good tight crimp onto the wire. The boot is locked in place and it can't move, and that'll work really well. Just so you know, these crimpers we have available, they're RMSTATOR terminal crimpers. They have 3 different size sizes in the die, so they work with all of our terminal and connector kits. So they're really useful. And you really have to have a set of these. You can get them other places as well, so you don't need ours if you already have a set. But you do need this type of crimper to crimp these correctly. So I'm going to go through and do all of these, and then we'll get them inserted into the connector. Okay, so we've crimped on all of our terminals and our boots. Now we're going to put the wires into the connectors. So we'll start with the stator wires. The stator wires can go in any order. There's no polarity to them. And on our regulators, the stator wires go in the gray connector. Okay, so if you look inside, probably be hard to see clearly, but there's a locking tab at the top here. And these terminals have a locking tab built into them. So they'll really only go in all the way one way if you orient them right. And you'll hear that click when you push them in. So if I try and put it in backwards, it just won't want to slide in. You'll feel resistance. So when you put it in right, which I'm holding it this way with the locking tab for the connector up, the locking hole in the terminal goes up as well. And if you line it up right, it slides in pretty easily, and you just push until you hear the click, and that tells you it's locked in place. Here's my third one. There we go. This was the one I didn't get a great crimp on the boot here, but your rubber boots on the wires should sit pretty much inside a little bit, or at least flush with the connector, and that seals the wire really well in the terminal inside the connector. Okay, the other thing we want to do is take the rubber boot for the connector, and it goes like this. See if I can get it all lined up right. Okay, goes around. I should have grabbed a little screwdriver to push it down with. Okay, it goes around the inside of the connector, and then it actually sits, and as you connect it to the regulator, it'll push down inside. It sits kind of at the base inside. Then the next thing you want to do is take your locking piece, and this is what locks the terminals in place, and it slides right over the front. And you push it until it latches in place and it sits flush with basically with the inside piece for the terminals. So once you've done that, you've totally sealed and locked this connector in place, and it's ready to be plugged in. Let me do the battery side, and then we'll plug it into the regulator. Okay, so here's the black connector, which is our battery side. If you see on this particular regulator, we're looking at the CNC housing. It might be hard to see, but it's because it's kind of light. But it's actually molded into the black side of the black connector on the bottom here. There's a plus right here on the inside terminal, and there's a minus on the outside terminal. So that tells you what side or what color wire, battery positive or battery negative, goes to which terminal. And you'll see the center, there's actually a third position in the center, but there's no terminal in it. It's not used, so we just leave that empty. Okay, so now that, I know which wire to put in which location. So I'm going to set this up like, here's my regulator, here's my new connector, and I know from looking at it, plus is on the inside, minus is on the outside. So I'm going to take my red wire, which is going to be battery positive. On most bikes it's red, but you might need to check your wiring harness or wiring diagram or look at your old regulator to determine that. And line it up, push it in. There we go. Then I'm going to take my negative side, which I used green is what I had sitting here on a reel, but a lot of bikes it's black. Hondas it's green often. On other bikes it could be other colors. Usually black though. And then I'm going to put it in the right location and push it in. So now if I look at the front, I have my connectors or my terminals pushed all the way to the front of the connector. I'm going to add the rubber seal around it, push it into place a little bit. And like I said earlier, a flathead screwdriver works well to push it down, but when you add your terminal lock here, it should force it down as well. Put that into place, push it in. I guess I have it pushing back against the rubber seal a little bit. So you might need to use a screwdriver and push the seal all the way in, but then you can push your locking terminal in place. Okay, so not much left. Your connectors are keyed and color coded. We'll see the little keying or locking tab here that only lets it plug in one way. We see we have the gray connector, and there's really not much to it. It just pushes on. Same thing with our battery side. The keying tab or terminal is on the opposite side, so you can't mix them up. And the color's different, obviously. Those line up and push in as well. So that's really it. It's really simple, and you know, like I said, you could pretend we did that on the bike, but if you're building your own harness, that's how you do it on the workbench as well. Okay, so now we're back at our bike and we have our new regulator mounted and installed. We like the location. We made whatever adjustments necessary to make it fit correctly. So all that looks good. And then we've already modified our wiring to put our new connectors on. So here we have our stator connector and the gray connector. We have the battery side and the black connector. And I'm not going to totally tie these up or anything because I'm doing more work on this bike, but we will go ahead and plug them in. So here's our stator side plugged into the gray, and here's our battery side plugged into the black. And obviously, if this was permanent right now, I'd route the wires nicely and tie them up and all, but this illustrates how to plug it in now that you modified your connectors. So that's it. I mean, it's really a pretty easy install, and you can apply this to just about any vehicle out there, so it's a nice upgrade on anything. On this Harley, I'm going with our CNC housing series regulator that works really well on these bikes that run super hot. So anyways, yeah, I hope that explains how to do it and shows you that you can make this work on just about anything. If I can do this on this crappy old Harley, you can definitely make it work on any of your vehicles. So it's a great upgrade on anything. So anyways, well, look, the next thing we're going to do, or the last step, we're going to test the charging system, because anytime we do work on the charging system, we need to know it's working well. So we'll check that out next, and that's about it. All right, so anytime you do any work on the charging system, you want to check it and make sure everything's working well. I'm just going to explain this, and then I'll start it up and show you, because this bike's too loud probably to talk over much. But what we're looking for is we want to connect our voltmeter. I'm using our RMSTATOR battery tester connected to the battery terminals, and we're looking for upwards of 14.5, 14.6 maximum at higher RPM, upwards of 3, 4, 5,000 RPM. And that'll tell us that, you know, we're getting a good charge at idle. We should see 13 volts or so at least, maybe higher. And then we should see upwards of 14.5 at high RPM. That tells us the charging system is working well and our voltage regulator is working well and limiting the voltage. So let's watch it and see what happens. So there's our idles, great. Okay, so we're getting good voltage depending on RPM, 13 to 14 at idle, and we're limiting at 14.5. So that says the charging system's working great and the regulator's working great. So this was a really nice upgrade on this Harley. Hey, make sure to subscribe to our YouTube channel. Leave any comments, let us know what you want to see next, or if you have any questions, and check out rmstator.com for any more information and all of our products.